Good day and welcome. This video contains information on shapes and area. The topic is geometry. Allow me to start with the most basic shape, a triangle. We all know that a triangle has got three vertices and the angles inside the triangle adds up to 180 degrees. We will use this property to now indicate how many degrees there is in the different shapes that we work with. So, if I look at any quadrilateral, meaning a shape with four vertices, I will cut it into triangles. So I will find two triangles. So I've got 180 degrees and 180 degrees. That will give me a total of 360 degrees. My next shape is a pentagon. If I cut this pentagon into triangles, I will see there's 5 sides and I will get 3 triangles, each 180 degrees. Altogether, it will come to 540 degrees inside. If I want to know for a regular shape, one of these angles, I divide that 540 by 5 and I get 108 degrees for each of these angles because it's a regular shape. Then, when I go to a hexagon and I divide this into triangles, I see a 6-sided object which has 4 triangles inside, each one of them having 180 degrees inside. So that gives me a total of 720 degrees. If I want to know the size of one of those angles, I divide it by 6. 720 divided by 6 gives me 120 degrees for each of these angles. Now, this hexagon was drawn inside a circle. I know that the radius is given as 11. So the length of this side is 11, the length of that side is 11. And when I work with a hexagon and I divide these angles, I find that there is 6 equal angles around the center. So this angle, this angle, this angle, this angle, and that angle are all the same size. 360 divided by 6 gives me 60 degrees per angle. Now, this takes me to another amazing factor, that this angle and that angle needs to add up to 120. But this is a radius and this is a radius, which means the angles opposite them has to be equal in size. So 120 divided by 2 gives me 60 degrees and 60 degrees, which makes this shape an equilateral triangle. All the angles are 60 degrees and all the sides are 11 meters long. Now the question was asked to calculate the area of this little section over here. Firstly, what I can do is calculate the area of this triangle. And we know that the area of a triangle is equal to half base multiplied with the perpendicular height. Now, if we construct a perpendicular height from the vertex to the floor, this will divide this in 2 equal pieces. So this will be 5.5, that will be 5.5. The perpendicular height will be 5.5 squared subtracted from 11 squared. So 11 squared is 121 minus 5.5 squared gives me a total of 90.75. But that is the square on this perpendicular height. I just want to know the height. So I find the square root of 90.75, and that gives me a height of 9.526279.442 meters. Now, to calculate the area of this segment, I will say half of the base, which is 11, multiply with the perpendicular height, which is 9.52. Taking this into account, I will now say the answer, when I multiply it, gives me a result of 52.39453693. For those who has done trigonometry and know to work with the sine rule, the area rule, know that you can calculate the area of a triangle without knowing the perpendicular height, but I've got two sides and an included angle. In this case, it's 60 degrees. I can say area is half AB sine C. So, half of 11 multiplied by 11 multiplied with sine of 60 degrees. And this gives me a result of 52.39453693, which is exactly the same answer, but that is one of those segments. Now we calculate the area of the 6 by multiplying by 6, and we get the answer 314.367216 meters squared. Now, I find the area of the circle. How do I calculate the area of the circle? Area of a circle is equal to pi radius squared. And in this instance, we were given that pi should be 3,1415. The radius we know is 11 meters. From the center to the outer perimeter of the circle is 11 meters. So radius is 11 and it must be squared. So this gives me 380.1215 meters squared. Now, if I only want this, I need to take the area of this whole section and subtract the area of the triangle, which was 314, and then divide the remaining area by the 6 sectors that is left. So, after I've done the calculation, my answer comes to 10,9090464 meters squared. That is the area of one of these segments that is available here. The word that was used in the assignment referred to a sector. So a sector is normally this whole part as indicated by the movement of the cursor. Right? When I talk about a segment, a chord divides the circle in a minor segment and a major segment. right? Everything above the chord is called the major segment, and at the bottom, the smaller part is called the minor segment. So when it spoke about or referred to a sector, I would have assumed that that whole section is a sector. But the part that was highlighted was just the one circular part there. That is a lot of information to consume, but remember, when I calculate the area of this one triangle, and I know now that this triangle is an equilateral triangle, from there I can deduce the following. I could use the area rule, or I could use area is equal to half base times the perpendicular height. And we calculated the perpendicular height by drawing a vertical line from the base to the vertex. And we know that because this is an equilateral triangle, this line will halve the base exactly. And because the base is 11 units long, this part will be 5,5 and that part will be 5,5. 5,5 squared plus an unknown length squared will give me the length on the hypotenuse squared, which we have as 11. 11 squared plus subtracting 5,5 squared gave me the 9,52 as the length of the perpendicular line. So we substitute in the place of the perpendicular line and we get the same value. We can look at the two values. Whether I use this method or that method, I got the same answer. Notice also that I did absolutely no rounding. Everything was the complete answer and I used it even till the very last. My final answer, I can round off to 10,96. How do I do this? I must round to 2 decimal places, so my degree of accuracy tells me I must stop at that point. Then I look at the next number, which is a 9. The 9 will make the 95 go to the next number, which is 96. Thank you for watching this video. If you liked it, tell your friends. If you loved it, tell everyone. I will see you in the next one. Do not forget to like, subscribe, and turn on your notifications to be notified when a new video is uploaded. Please share if you found this video useful. Goodbye.